It seems that everybody and their mother have an OBJ importer for OpenGL tutorial out there, but no one seems to have tackled skeletal animations in OpenGL except for Thin Matrix, but his way is arguably slow and not very portable. Today I'll try to explain as best as I can how you can add a skeletal animation system to your game without much hassle using the OpenAsset import library. LWJGL3 came with a lot of new nifty libraries. One powerful yet overlooked library is Assimp. Assimp is a C++ library that eases the process of importing some of the very popular file types, such as the ones you can see on the screen right now. But it seems that no one even mentions that Assimp has been added to LWJGL3, probably because they're too busy making OBJ importers. And it might not seem like a big deal at first, but Assimp is a very useful library, and it can really help optimize and speed up the initialization stage of your game. Now to get started with the tutorial, you're going to need a sample engine. Instead of writing a simple test engine, I decided to use BennyQBD's Java engine, which is also available for C++ developers out there. So if you want to follow along with a different language, the process is going to be the same, or you can download an LWJGL3 compatible version of the engine that I made. The second thing that we're going to need is Assimp, and if you're going to follow along in C++, the C++ version of the engine that we'll be using should have a CMake dependency for Assimp. Regardless, all the links to the downloads will be in the description. So as I mentioned earlier, I will try to make my code as portable as possible, so you can use the same code on your existing game, and theoretically, it should work with as little change as possible. So I start here by creating a class and call it the animation util. It is going to be a class with a bunch of static methods that are going to be used to create our animation components. And we currently don't have an animation component class, so I'm just going to go ahead and create that. And it's going to be empty for now. And in here I start by creating an AI scene, which is an Assimp class. So this method takes a file location and it imports vertices and data from file. We can actually load from memory using text or whatever other kind of file that we already loaded into memory, but today we're using this method. In here, Assimp takes flags, is what it calls them. They're just basically how you want to import your file. The only thing we're doing here is we're importing triangulated faces, and we're generating smooth normals if there aren't any on the file. We're flipping the texture coordinates. We are calculating the tangent space normals and limiting the bone weights. After that, I do a check so that we know that the scene is not empty or that the scene is not null. So that way we know that we have imported a file that contains an animation and a skeletal mesh. The error handling on this method is not very good. I'm exiting, which means I'm quitting the whole game, so you should probably make your error handling a bit different. This is just an example. And in here I'm creating an AI mesh, and we're getting the first mesh that exists in the AI scene. There could be more, so make sure to check out the Assimp docs. And in here, I'm just going to define a size for a vertex. And then I create an array the size of the number of vertices that exist in this mesh multiplied by the size of a vertex. Currently it's 0, but we're gonna figure out what the actual number is. So the size of a vertex is dependent on how many components are in it. There's position data, that's 3 floats. There's normal data, that's 3 floats. There's tangent space normals, that's 3 floats. There's text coordinate data, or texture coordinate data, that's 2 floats. And then we have 4 floats for bone information and another 4 floats for bone information. In total it should be 19, but I made a mistake in here and wrote 15. Then in here I'm going to loop the size of the vertices. Here we're going to retrieve the position and normal information. Then the tangent information. And in here the texture chord information, which is also AI Vector 3D for some reason. So in here I'm making a little comment saying that the above assumes that the file format has texture information. So make sure that if you're not sure that you have texture information in your file, to make an if statement to check if there is texture information. And then in here I just make an index so that I can use the index to index our array. And then I just copy it for the other data. So in here I'm just putting all the data that we gathered from Assimp, and I'm putting it in a float array so that we can upload it to the GPU later. And in here I'm just initializing the bone information to 0, because we're going to do that later in a different for loop. And in here, as you can see, I realized my mistake. It should be 19, not 15. And we should have 2 4D vectors for bone information. And in here, I'm just creating the list for the indices. And that's also simple. I'm just getting the number of faces and I'm multiplying it by how many indices are in a face. Then we loop the faces, and then we are looping the indices of the faces. And in here, I'm just retrieving the face at this specific index in the first loop. And then I just do the same thing that I did earlier with the other array. I increment the index variable, and then I set whatever is at that specific index to the face index that we want. And you have to make your index equal 0 first before you actually do the loop, because that way you won't get any index out of bounds exception. And here I realized that BennyQBD has already made a function in a class called util that creates an int buffer. So in here I just changed the code so that it just appends the index to the int buffer instead of to an array of integers. This way is faster, considering we're already gonna make it into an int buffer eventually. And here I create 2 hash maps to store our information for the bones, and you're gonna understand why in a minute. I'm creating a for loop that loops all the bones, and then I retrieve the bone, And then I create another hash map to store all the bones in, which you don't need to do because I never used it in the end. And then we loop all the weights in the bone, and then as usual we retrieve the weight from the bone. And in here I just need to know which vertex this bone information applies to. So we get it from the weight object. And then I check if the hash map we created earlier contains this vertex. And here I'm creating another variable called fIndex, which is going to be the vertex index multiplied by the size of a vertex. And then I create another variable called unrigged, and that is what we're going to use. It's going to be equal to 11 because it is the same size of a vertex minus 8, which is the bone information. And in here I just set the bone information in the array. And 0 in the array is going to be equal to the bone ID, and 2 in the array is going to be equal to the weight of that bone on this specific vertex. So in a 4D vector it would be x and z. And then on the second bone information, we're gonna append to that by 1. And this whole thing just makes sure that we do not have more than 4 bone weights per vertex. And in here, I set up the hash map. On the first step, we make it to 0. The second step, we make it to 1, so it doesn't use the first hash map anymore. We do the same thing with the other hash map, and everything should be working now.
Alright, so the next thing that I did was create a inverse root transform matrix, which is just the matrix that resides in the root node of this scene. And I'm using the Assimp matrix, AI matrix 4x4, but I wrote a conversion method that converts it to a matrix that the engine can use. Next, we're going to create an array of bone, which doesn't exist yet. We need to create the class, but I'm going to do it later. And the bone class is going to hold 2 important pieces of information, which is the offset matrix and the name of the bone. But I don't really put the name of the bone yet, so I'm going to do it later. And I'm creating this method, but we're not really using it anywhere, so feel free to exclude this method. Next, we populate the array using the bones that exist in the mesh. And it's really simple. We just create a bone. Then we create a new instance of the bone class that we created, and we place it in the array. Then we just assign the offset matrix and the name. Then we go to the animation component, and we first create a matrix, which is going to be the global transform matrix. Then we create the bone array, then an array that contains the bone transformations after we calculate the animation. Then the AI node, the root node of the scene, and an animation which we're going to use to animate our mesh. Now you shouldn't be doing what I'm doing in here. This is just an example showing you how to do animations. But you should really write your own classes instead of using the Assimp classes, because you should free the classes after using them. Then I'm just creating a simple method which creates the mesh and uploads it to OpenGL. And I'm just copying from the mesh class that the engine already has, just to save time. And then I change it, instead of a list of vertices, we take a float buffer. And instead of an array of indices, we take an int buffer. And then I remove the boolean at the end because we don't use it. Then we pass on the buffers, and we're pretty much done with uploading the information of the mesh. Next, we write the method that renders the mesh. But first, I make the class extend game component so that it can be included in a game loop. And then I create a shader that we're going to use to render the mesh, because we need a special shader that's going to be able to handle animations. Then we bind the shader and update the uniforms. And I create a material just so that we can use it with the shader. So in here I copy the ambient shader and then do a few changes to it, mostly in the Vertex shader. And I change it to version 440. And then I take a uniform array of matrix 4f, which is going to be the bone transformations that we calculate. And then I mix all the bones using the bone IDs and the bone weights of the vertex. And then we multiply this vertex by the position. And then that's pretty much it for the Vertex shader. And then in here I go back to the code that imports the mesh, and I create a float buffer for vertices and the animated component. But make sure to use the float buffer earlier in your steps. Make sure to populate it earlier. And then I flip the buffers and then add the vertices and then return the component. In here I forgot to make one little thing, which is use assimp.ai free scene, and then that frees the scene. But you can't do it in this code because we use the AI animation. So if you write your own classes that supplement the Assimp classes, then make sure to free the scene. Then in here, I go to the game, to the test game, and then I just add the animated component that we created, and then we just load the animation file, and then I create a file in Blender, which you're going to see now, and then I'm going to import it. This is pretty much everything for this tutorial. I'll leave the code in the description. You're going to find it, you can read it, it's going to be very simple. The only problem is I can't show you, I can't explain how to write the calculation of the animation because it's really lengthy code and it would take really long time. So it's self-explanatory, but it's really lengthy. So just make sure to look at it in the animated component in the code that I will share.